Hello everybody and welcome to another Mystery Box Function Challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. Because it's Friday, that math is going to be extra challenging today. You can use the link in the description to try this out, and when you think you've got an idea, come on back, see if we get the same thing. All right, I'm going to start with a 0. Oh, so 0 gives us infinity. So let me start taking notes right away. When I see infinity as an answer, well, this is really an error, not a true answer. I think of rational functions. So I'm just going to put this 1 over x here. I'm sure it's going to be more complicated than that, but that's what I start to think of. Let's put in some more numbers. So 1 gives us 2. How about a 2? 0.5. How about a 3? Oh, interesting. I'm going to put some further out. How about a 7? Oh, how about a 9? All right, let me put in some fractional values, because if this is a rational function, it should do something funny when it gets close to the y-axis. So let's do, let's do 1/2. And maybe 1/4. And maybe let's do 1/8. Yeah, so you can see the shape we're getting here. It's an odd one. We haven't seen one like this before. It's approaching the y-axis as an asymptote here vertically, but we're used to seeing it approach the x-axis or some horizontal line most often as the other asymptote. Here we've got a diagonal. That's interesting. Let's just put in some negative values to see what's going on. What I'm expecting, if this is the rational function that I think it is we're going to see a similar shape over here in the third quadrant. So let's put in a -1. And a -2. Now let's go ahead and put in a -7. And a -9. I think we're getting some symmetry around around the origin here. You can see when we put in a +9, we got this 9.111. When we put in a -9, we get a -9.11. I've got too many numbers that are overflowing my chart, so things are going to get off here. But I want to put in a couple of fraction values in the negatives here. So -1/2. And -1/4. So it looks like we're getting very much the same shape down here. So what could this be? Well, there are 3 different kinds of asymptotes that rational functions can have. There's the vertical asymptote, and here the vertical asymptote is you know, x equals 0. So what that means when you see that vertical asymptote of x equals 0 is that the bottom of the fraction is going to be 0. So I'm thinking maybe just x is on the bottom, or something that would come out to 0 if you put in an x. I don't think it's x squared. Maybe it's x cubed. I don't know. Actually, I don't think that either. But something that's going to be 0 when you put in 0 for x. So that's what we're looking for on the bottom. The horizontal asymptotes we've seen before with 1 over x that has a horizontal asymptote. We haven't seen these, and I'm actually going to choose a different color here. I think we have a diagonal asymptote. So both of these functions, both of the branches of this function are approaching the same diagonal line, but never quite reaching it. And just as I've drawn it in here, it looks like that line is just y equals x. So what does that tell us? Well, when you see a diagonal asymptote, a slant asymptote, they're called, what that means is the degree of the top is bigger than the degree of the bottom. So let's see, the simplest thing you could probably have is x squared over x. But x squared over x, that would just simplify to x. So you'd just get this line, except it wouldn't be defined at 0. 0 would still be infinity. That's not exactly what's going on here, because when I put in 1, I'm getting out 2. So how could we do that? If we put in 1, just like this, we could get out 1. So I suppose we could either multiply this by 2 or add 1. when I put in 2, that would be 2 squared on the top and 2 on the bottom. That would give us 2. If I multiplied that by 2, that wouldn't work out. So let's just try the add 1 to get to 2. Okay, so at 0, that's going to be infinity because you'll have a 0 on the bottom. At 1, you'd get 1 squared plus 1. That's 2 over 1. That's 2. How about, let's try it 3. So 3 squared plus 1 over 3. So 3 squared is 9, so that'd be 10 over 3. So that would be 10 thirds, and that is 3 and 1/3. And look, at 3, we've got 3 and 1/3. So I think we probably have this, the slant asymptote. You get this equation of the slant asymptote by actually dividing the numerator by the denominator. So if we took x squared plus 1 and we divided that by x, you'd ask, okay, what do I multiply x by to get x squared? And the answer would be x. X times x is x squared. You'd subtract and you'd get a remainder of 1, and your result is x. That's the going to give you that right-hand side for the equation for the line. So that matches what we see on the graph here. So I think we've got this. Let's take a look. Yeah, there it is, x squared plus 1 over x, and let's graph it as well. Pretty interesting looking graph. You get these two arms, but approaching asymptotes that are vertical and slant. Well, how did that go for you? I think that one was super, super hard. But let me know. Thanks, everybody.